Good morning. Today, let's continue the discussion of constructing the ellipse. I said there are four methods in our syllabus to construct the ellipse. We have already discussed three methods in the other classes, right? So let us go for fourth method, namely concentric circles method. The construction of ellipse by concentric circles method. So here, the name is giving some suggestion, right? Concentric circles. What do you mean by concentric circles? Concentric circles means they are the circles drawn with the same center but with a different radii, right? Circles with the same center but with different radii. So they are called concentric circles. So we'll be drawing concentric circles. Well, so let us take up one question. So here it is, draw ellipse by concentric circles method. Take major axis 100 mm and minor axis 70 mm long. So straight away, so these are the two parameters that we require to follow this method and get our ellipse construct, right? So they are given, major axis and minor axis are required to follow this method, and in the data also they are given straight away. 100 mm and 70. As we know, these two axes are mutually perpendicular bisectors, therefore place them symmetrically above the midpoint. So next, these are the step-by-step construction steps, but you just follow this construction step-by-step. Instead of reading them now, this text is given, construction steps are given in text that you can see later on, but see the construction step-by-step. So draw the horizontal line, which should be equal to the major axis, 100 mm, and represent the minor axis. And you know already they are mutually perpendicular bisectors. So after writing the horizontal line, find the midpoint. Horizontal line is equal to major axis, that is 100 mm. So find the midpoint, and through that write a perpendicular line on that, as minor axis is 70 mm. So from midpoint on either side, you go for 35 mm to terminate that minor axis, right? The names AB and CD. AB is the major axis and CD is the minor axis. And so now, taking the minor axis as diameter, you have to draw a circle. So taking this major axis and minor axis as diameters, you draw those concentric circles. As I said, concentric circles are the circles which are drawn with the same center but with a different radii. So here, taking this major axis and minor axis as diameters, draw the concentric circles. Right? Next, this is easy. And now divide these circles into certain number of equal parts, depending upon the size of these circles. If it is too big, go for 16. If it is 100 mm and 70 mm, go for 12. If it is somewhat less, let's say, you can go for even 8 equal parts as well. But here, taking the size 100 mm and 70 mm, it is better you go for 12 equal parts. And always do it by geometry. As I suggest, I advise you to get these divisions of the circles by geometry. That would be nice. If you practice that, that would be nice. Other measuring angles and all that, wherever it is, where there is no other way. It is mandatorily you have to do that. Means there is no other go. Then you can go for measuring the things. But normally, you get all the things by geometry because this is engineering graphics, right? So whatever it is, we have already discussed them in the other geometry constructions classes. You know them right from the school days. So that's not a big thing, but try to get them by geometry. So these circles have been divided into 12 equal parts. If you look at the figure, the diametrical lines are intersecting the circles at different points, both the circles. So outer circle, the naming is division points as 1, 2, 3, 4, 5, 6, 7. That. And on the same lines, we just confirm, let's match, let's say. The division points on the same diametrical lines, we given the same names. Even on the division points and even on the inner circle, we given as 1, 2, 3, 4, 5. As 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Like that. Okay? Next. From the points on the outer circle, from the division points on the outer circle, you write vertical lines inwards. Circle inwards means towards the center. So from, as you see from there, it's okay, little bit here, technical error, let's say. The vertical lines should be drawn from very exact points of intersection. Very exactly, you have to get them very exact. Accuracy is more important. That's why we use drafter and scale, compass, and all this, protractor, all these things, because in order to get the accuracy, we use them. So therefore, don't do them casually. So from 1, 2, 3, 4, 5, 6, which are on the outer circle, draw vertical lines inwards from 1, from 2, 3 is all there. We don't require another point because C is the end point. So you don't need to write any vertical line from 3, but that itself coincides with that. So from 4, from 5, from 6, inwards. So it is not, okay, from 10, 9, coming in reverse, 7, inwards. That means points in the upper half, from points in the upper half, you are drawing downwards, and from the points in the lower half, you are drawing the vertical lines upwards. That means inwards. Center is in the middle. So from above, you have to come towards the center, and from below, you have to go towards the center. That is what inwards means. And from now, horizontal lines outwards from the points on the inner circle. Right? Horizontal lines outwards from the points on the inner circle to intersect the previous vertical lines. Step by step, in series, in correct sequence. So from 1 on the inner circle, you draw a horizontal line to meet the vertical line which is drawn from 1. In the first case, from the points on the outer circle, you are drawing the vertical lines inwards, and from the points on the inner circle, you are drawing the horizontal lines outwards. So from 2. So next, the point is 4, so you are drawing outside. So we got the points of from the 4, you're drawing outwards. That means away from the center. From 5, 6, 7, 9, 10. So these are the points of intersection. Both the points of intersection of vertical and horizontal lines. Right? So they are our points which have to be connected in sequence. That is point 1. Point 2 in the first quarter of the space, and that is already there. That is the end point of the minor axis. You must get your curve pass through it, which passes through that. Next one is this. These are the 2 points in the other quarter. This is the end point of the major axis. This 6 and 7, obviously these are the points in the third quarter. And this is another end point of the minor axis, 9, 10, and finally 8. So connecting all these points with a freehand sketch. Initially draw with light, and get them exact, accurately. You need to pass through those A, B, C, D, E, D, and passing through all the found out points. Is getting. And one more thing I've been forgetting, and don't forget about dimension. Always in the first year syllabus, we discuss this engineering graphics with respect to shape and size. Shape, that means we are giving geometrical property. Geometric property means shape and as well as size also. Size does matter. The obvious dimensioning is very, 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 very important part of this practicing engineering. So give that. So what are given in the data, that should be mentioned, that should be indicated on the drawing. AB is the major axis, you have to write major axis length. The dimensioning also should be given, and it is not there here. Anyway, you have to draw them, right? Perpendicular lines from A and B. And between those two vertical lines, you have to draw a horizontal line, taking at least 10 mm away from the main figure. Suppose a main figure here, if you draw vertical lines downwards from A and B, draw. And then you have to draw the horizontal line, which is called dimension line, right? That dimension line should be at least 10 mm below that number 8. You are looking at that, you are able to see the division point 8 from there, because that is the outermost point downwards of the ellipse. So from there, it should be at least 10 mm. So at that place, you write a horizontal line between the vertical lines drawn from the A and B, and write those vertical lines from A and B lightly, and the horizontal line between those vertical lines, which is called dimension line, that also lightly. And at that points, you have to get the arrowheads such that the tips should be touching exactly, accurately, definitely at those vertical lines. So that is, keep them light, but write arrowheads and fill them, and right above the line always. That is major axis is 100, and you write to 100. Because normally always, except the topic of scales, we'll be dealing the things, we'll be measuring the things in generally millimeters here. So you can leave a note, all dimensions in mm. So you put that while dimensioning that, you can just write the digits on the drawing sheet, right? And next, minor axis. From C and D, you write horizontal lines, and in the same way, you write a vertical line, and that vertical line should be at least 10 mm away from B on the rightmost point. B is the rightmost point of the ellipse. So from there, you keep 10 mm and write a vertical line, which is dimension line, between the horizontal lines which are drawn from C and D. So that is what dimensioning is. And here, when you are, how to put that 70, because the minor axis length is 70. So how to write that? You can write in two ways. One is as it is, when you look from the front, right, like 100, just besides that vertical line, leaving just 1 mm gap, right in the center, middle of the line, you write 70 as we look from the front. Or else you can go like this. If you can read a drawing sheet, you can read the drawings on the drawing sheet from the front or from the right side. You cannot see from the left side. So always when you look from the right side, keep the line. If you want to write along the line, write above the line, that's 7. When you look from the right, it should be above the line, right 70 in the middle of the line, leaving just 1 mm gap from the dimension. So they are very, very important, don't forget. And obviously keep the circles and division, the diametrical lines which are drawn for dividing equally, and the vertical lines drawn, the horizontal lines drawn, and the extension lines, dimension lines, whatever you write, keep all of them lightly, because finally our ellipse should be glaringly visible in a very crowd. There are so many lines we draw, so finally our objective is to get the ellipse, right? So your drawings must be very beautiful, legible, clear for the reader, right? So that is what getting the ellipse by the concentric circles method. With this, we have finished all the special methods for the next, ellipse. So in the next class, we will go for the special methods for ellipse, parallel. Right. Okay, right.